Both the National Electrical Code in the United States and the International Electrotechnical Commission standards in other countries generally require overcurrent protection for all electrical equipment. According to National Electrical Code Article 430.32, (1) Motors rated 1 horsepower or less and operating on circuits rated not over 50 volts shall be protected by fuses or circuit breakers. Since the rotary electric vibrator operates below 1 horsepower and the circuit voltage is below 50 volts, it would typically not require overcurrent protection as per the National Electrical Code. International Electrotechnical Commission 60364.4 412,017, which applies to low-voltage electrical installations, requires overcurrent protection for all electrical equipment against short-circuit currents and overload currents. Since the rotary electric vibrator has an amp draw of 0.25 amps, it is unlikely to cause a short-circuit current. However, it may be susceptible to overload currents if the vibrator becomes stuck or malfunctions. Despite the potential code requirements, it is generally good practice to provide overcurrent protection for all electrical equipment, including rotary electric vibrators. This is especially true for portable equipment that may be subjected to rough handling or misuse. Firstly, it protects the vibrator from damage due to overload currents. Secondly, it protects the circuit from overheating and potential fire hazards. Thirdly, it provides a means of isolating the vibrator in case of a fault. A small motor starter with a thermal overload relay would provide suitable overcurrent protection for the rotary electric vibrator. The relay should be sized to trip at an appropriate current level to protect the vibrator without nuisance tripping. Although the specific code requirements may vary depending on the jurisdiction, it is advisable to provide overcurrent protection for rotary electric vibrators used in portable equipment. This will help ensure the reliability and safety of the equipment and its users. The National Electrical Code addresses motor protection extensively, outlining specific requirements based on motor size, type, and application. Article 430 covers these requirements in detail. Overcurrent protection is designed to protect motors and their control equipment against excessive currents, whether caused by overloads, short circuits, or ground faults. Overload protection, specifically, is intended to protect the motor from damage due to sustained overloads, such as when the motor is operating under excessive mechanical load. Short circuit and ground fault protection are intended to protect against immediate and severe fault conditions, such as a short circuit within the motor windings or a ground fault to the motor frame. For small motors, such as those less than 1 horsepower, the protection requirements may be less stringent than for larger motors. However, even for small motors, some form of overcurrent protection is generally required. This can be provided by fuses, circuit breakers, or thermal overload relays. The specific type and size of overcurrent protection device will depend on the motor's full load current rating and other factors such as the motor's starting characteristics and the type of load it is driving. Thermal overload relays are commonly used to provide overload protection for motors. These relays are designed to trip when the motor current exceeds a predetermined level for a specified period. The trip time is typically inversely proportional to the current, meaning that the relay will trip faster at higher currents. This provides protection against both short-term and long-term overloads. Fuses and circuit breakers can also be used to provide overcurrent protection for motors. Fuses are single-use devices that melt and open the circuit when the current exceeds their rating. Circuit breakers are reusable devices that trip and open the circuit when the current exceeds their rating. Circuit breakers can be reset after they trip, while fuses must be replaced. When selecting overcurrent protection devices for motors, it is important to consider the motor's full load current rating, the motor's starting characteristics, and the type of load it is driving. The overcurrent protection device should be sized to protect the motor against overloads and short circuits, but it should also be selected to avoid nuisance tripping. Nuisance tripping can occur if the overcurrent protection device is too sensitive or if it is not properly coordinated with the motor's starting characteristics. In addition to the National Electrical Code, other standards and regulations may apply to motor protection depending on the application and location. For example, the International Electrotechnical Commission standards may apply to motors used in international applications. These standards may have different requirements for overcurrent protection than the National Electrical Code. It is important to consult all applicable standards and regulations when selecting and installing overcurrent protection for motors. Proper overcurrent protection is essential for ensuring the safe and reliable operation of motors. By providing adequate overcurrent protection, you can protect motors from damage due to overloads, short circuits, and ground faults. This can help to extend the life of the motor and prevent costly downtime. When dealing with equipment used outside the United States, it's crucial to consider the applicable local electrical codes and standards. These codes often differ significantly from the National Electrical Code and are tailored to the specific electrical systems and safety practices in each country. International Electrotechnical Commission standards are widely used as a basis for national electrical codes in many countries. However, each country may have its own variations and additions to these standards. Therefore, it's essential to consult the specific electrical code for the country where the equipment will be used. Voltage levels and frequency are among the most important differences between electrical systems in different countries. The United States uses 120 volts and 60 Hz, while many other countries use 220 to 240 volts and 50 Hz. Equipment designed for one voltage and frequency may not operate correctly or safely on another voltage and frequency. Therefore, it's essential to ensure that the equipment is designed for the voltage and frequency of the electrical system where it will be used. Plug and receptacle configurations also vary widely between countries. The National Electrical Code specifies the plug and receptacle configurations used in the United States, but these configurations are not used in other countries. Each country has its own set of standard plug and receptacle configurations. Therefore, it's essential to ensure that the equipment is equipped with the correct plug for the country where it will be used. Grounding practices also vary between countries. The National Electrical Code specifies the grounding practices used in the United States, but these practices are not always followed in other countries. Some countries use different grounding systems, such as the TNS system, the TNC system, or the IT system. It's important to understand the grounding practices in the country where the equipment will be used and to ensure that the equipment is properly grounded. Overcurrent protection requirements can also vary between countries. While most countries require overcurrent protection for electrical equipment, the specific requirements may differ. For example, the type and size of overcurrent protection devices may vary, as well as the requirements for coordination between overcurrent protection devices. It's important to consult the local electrical code to determine the specific overcurrent protection requirements for the equipment. In addition to the electrical code, other standards and regulations may apply to electrical equipment used in different countries. For example, product safety standards, such as those issued by Underwriters Laboratories or the Canadian Standards Association, may be required for certain types of equipment. It's important to consult all applicable standards and regulations to ensure that the equipment meets the requirements for the country where it will be used. When exporting electrical equipment to other countries, it's essential to work with a qualified electrical engineer or consultant who is familiar with the electrical codes and standards in those countries. These professionals can help ensure that the equipment is designed and installed correctly and that it meets all applicable requirements. This can help to avoid costly delays and ensure the safe and reliable operation of the equipment. Rotary electric vibrators are commonly used in a variety of industrial applications, including material handling, conveying, and screening. They are used to vibrate materials such as powders, granules, and aggregates to promote flow, compaction, or separation. These vibrators typically consist of an electric motor with an eccentric weight attached to the shaft. When the motor rotates, the eccentric weight creates a centrifugal force that causes the vibrator to vibrate. The amplitude and frequency of the vibration can be adjusted by changing the size and position of the eccentric weight and the speed of the motor. Rotary electric vibrators are available in a wide range of sizes and configurations to suit different applications. They can be mounted on a variety of surfaces, such as bins, hoppers, screens, and tables. They can also be portable, allowing them to be moved from one location to another as needed. When using rotary electric vibrators, it's important to consider the electrical safety requirements. These vibrators can generate significant electrical currents, so it's essential to ensure that they are properly grounded and protected against overcurrents. It's also important to follow the manufacturer's instructions for installation, operation, and maintenance. Overcurrent protection is essential for protecting rotary electric vibrators against damage due to overloads, short circuits, and ground faults. Overloads can occur when the vibrator is subjected to excessive mechanical load, such as when the material being vibrated is too heavy or when the vibrator is jammed. Short circuits can occur when there is a fault in the electrical wiring or components of the vibrator. Ground faults can occur when the electrical current leaks to the ground. Overcurrent protection devices, such as fuses, circuit breakers, and thermal overload relays, are designed to trip and open the circuit when the current exceeds a predetermined level. This protects the vibrator from damage and prevents potential fire hazards. The size and type of overcurrent protection device should be selected based on the vibrator's full load current rating and other factors, such as the vibrator's starting characteristics and the type of load it is driving. It's also important to coordinate the overcurrent protection device with the other electrical components in the circuit to ensure that it will trip before any damage occurs. In addition to overcurrent protection, rotary electric vibrators should also be properly grounded. Grounding provides a path for electrical current to flow safely to the ground in the event of a fault. This helps to prevent electrical shock hazards and reduces the risk of fire. The grounding conductor should be sized according to the National Electrical Code and should be connected to a suitable grounding electrode. When installing rotary electric vibrators, it's important to follow the manufacturer's instructions carefully. The instructions will provide guidance on how to mount the vibrator, how to connect the electrical wiring, and how to adjust the vibration amplitude and frequency. It's also important to inspect the vibrator regularly for signs of wear or damage. If any problems are found, they should be repaired promptly to prevent further damage or safety hazards. Regular maintenance is essential for ensuring the long life and reliable operation of rotary electric vibrators. This includes lubricating the motor bearings, cleaning the vibrator housing, and inspecting the electrical wiring and connections. It's also important to check the eccentric weight and adjust it as needed to maintain the desired vibration amplitude and frequency. By following these guidelines, you can help ensure the safe and efficient use of rotary electric vibrators in a variety of industrial applications. Remember that specific requirements may vary depending on local codes and regulations, so always consult with a qualified electrician or engineer for specific guidance. The amp draw of 0.25 amps is a relatively small current. In electrical terms, a low current draw like this means the device consumes a small amount of electrical power. However, even small currents can be dangerous under certain conditions, such as in the event of a short circuit or ground fault. That's why overcurrent protection is still important even for devices with low amp draws. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a predetermined level, regardless of how small or large that level is. This helps to prevent damage to equipment and reduces the risk of electrical shock and fire hazards. The concept of a short circuit is critical in electrical safety. A short circuit occurs when electrical current bypasses its intended path and flows through an unintended path with very low resistance. This can result in a very high current flow, even if the normal operating current of the device is low. For example, if the 0.25 amp rotary vibrator experiences a short circuit, the current could surge to hundreds or even thousands of amps in a fraction of a second. This rapid increase in current can cause wires to overheat, insulation to melt, and components to explode. Overcurrent protection devices are designed to detect and interrupt these short-circuit currents before they can cause damage. Ground faults are another important consideration in electrical safety. A ground fault occurs when electrical current leaks to the ground. This can happen if the insulation on a wire is damaged or if a conductive object comes into contact with a live electrical component. Ground faults can be dangerous because they can create a path for electrical current to flow through a person's body, resulting in electrical shock. Overcurrent protection devices, particularly ground fault circuit interrupters, are designed to detect and interrupt these ground fault currents before they can cause harm. The use of a switch alone, without overcurrent protection, is generally not recommended for electrical equipment. A switch is simply a device that opens and closes an electrical circuit. It does not provide any protection against overloads, short circuits, or ground faults. Therefore, relying solely on a switch to protect electrical equipment can be dangerous. Overcurrent protection devices such as fuses, circuit breakers, and thermal overload relays should always be used in conjunction with switches to provide comprehensive protection against electrical hazards. In the specific case of the rotary electric vibrator, the fact that it is mounted on portable powder dispensing equipment on a two-wheeled dolly adds another layer of complexity to the electrical safety considerations. Portable equipment is more likely to be subjected to rough handling, physical damage, and exposure to moisture and other environmental factors. This increases the risk of electrical hazards such as short circuits, ground faults, and insulation damage. Therefore, it's even more important to provide adequate overcurrent protection and grounding for portable equipment. The use of a motor starter with a thermal overload relay is a good practice for protecting rotary electric vibrators, especially those used in portable applications. A motor starter is a device that provides a controlled start and stop for an electric motor. It typically includes overload protection, as well as other features such as undervoltage protection and phase loss protection. A thermal overload relay is a type of overcurrent protection device that is specifically designed to protect motors from overloads. It works by sensing the motor current and tripping when the current exceeds a predetermined level for a specified period. This helps to prevent damage to the motor due to overheating. While some may claim that a motor starter with a thermal overload relay is not required by any code, it is generally considered a best practice for protecting motors and ensuring electrical safety. Even if the code does not explicitly require it, providing this level of protection can significantly reduce the risk of electrical hazards and extend the life of the equipment. Remember to always consult with a qualified electrician or engineer to determine the specific electrical safety requirements for your application. They can help you select the appropriate overcurrent protection devices and ensure that they are properly installed and coordinated.